Calculating median from less than distributions. Welcome, everyone. Today, we are going to tackle a specific challenge in statistics, calculating the median from less than distributions. Now, you might be used to seeing data presented in a standard grouped frequency table, where each class interval has its own clear frequency. However, in many real-world statistical problems, data isn't provided that simply. Instead, you will often encounter what we call a less than cumulative frequency distribution. This can look a bit confusing at first because the numbers are cumulative rather than individual. Because of this, we cannot jump straight to our usual median formula. As we will see in the upcoming slides, the key to solving these problems is a crucial preliminary step. We must first transform this cumulative data back into a standard frequency distribution. Once we have converted it, we can then apply the standard median formula just as we always have. Let's move on to the next slide to understand exactly what these less than distributions actually represent. Understanding less than distributions. Now that we know we aren't dealing with a standard frequency table, let's really dive into what a less than distribution actually represents. Think of it this way. A less than distribution doesn't just give you the count for one specific group. Instead, it provides the cumulative frequency. This means it tells us the total number of observations that fall below a specific upper limit. To make this clearer, let's look at this example. Suppose you see a table that states less than 50 kilograms has a frequency of 15. This doesn't mean exactly 15 people weigh 50 kilograms. Rather, it means that 15 people in this entire group have a weight that falls anywhere from the very lowest recorded weight all the way up to that 50 kilogram mark. So, the most important thing to remember as we move forward into our conversion steps is this. The values you see listed in that less than column are not the frequencies for individual groups, but they actually represent the upper limits of our class intervals. Keep this in mind, because in the next few slides, we are going to learn exactly how to use these upper limits to build our standard intervals. Step-by-step process for conversion and calculation. Now that we understand what a less than distribution actually represents, we aren't going to jump straight into the calculation. Instead, we are going to follow a clear, systematic, four-step process to transform this data and find our answer. Let's look at these steps one by one. Step 1. Determine the class intervals. First, you need to look at the table provided in your problem and identify the upper limits. Remember from our previous slide that in a less than distribution, the values given are actually the upper boundaries of each group. Next, once you have these upper limits, you need to find the class size, which we denote as h. You can do this by calculating the difference between any two consecutive upper limits. This tells you the width of each interval. Finally, we use these upper limits and the class size to establish the lower limits, which allows us to create standard class intervals. For example, if your upper limits are 20, 30, and 40, you can see the difference between them is 10. Therefore, your standard intervals would be 10 to 20, 20 to 30, and 30 to 40. This transformation is crucial because, as we will see in the next step, we cannot work with the data until we have these distinct, standard intervals ready for our frequency calculations. Now that we understand what a less than distribution represents, let's move into the actual procedure. In this fourth slide, we are looking at the very first step of our process, determining the class intervals. Step 2. Calculate individual frequencies. It is vital to remember that the frequencies you see listed in a less than table are not the individual frequencies for each group. Rather, they are cumulative frequencies, which we denote as CF. To find the specific frequency, which we call F, for any particular class, you'll follow a simple subtraction rule. For the very first class in your table, the frequency is simply equal to its cumulative frequency, because there is no previous group to subtract. However, for every class that follows, you must subtract the cumulative frequency of the preceding class from the cumulative frequency of the current class. In mathematical terms, you can think of it as the frequency of the current class equals the cumulative frequency of the current class minus the cumulative frequency of the previous class. Now that we know how to identify our class intervals from the upper limits, we need to address the most critical part of this process: finding the actual frequencies. Once you have applied this subtraction to every row, you will be ready to move on to the next step, which is constructing your new standard frequency table. Step 3. Construct the standard frequency table. Now that we have understood how to find the individual frequencies in the previous step, we need to organize all our hard work. For step 3, you are going to construct a brand new, standard frequency table. This table should be clearly laid out with 3 essential columns. First, your newly determined class intervals. Second, the individual frequencies, which we denote as lowercase f. And third, the cumulative frequencies, which we denote as lowercase cf. Having this organized table is crucial because it serves as the foundation for the next step, where we will identify the median class and apply our formula. Step 4. Apply the median formula. Now that we have gone through the steps of converting our less than data into a standard frequency table, we reach the final and most crucial step: applying the median formula. Once your standard table is fully prepared, your first task is to identify the median class. This is the specific interval where the middle value of your data resides. Once you have located that class, you will plug your values into this formula. Median equals L plus all over F, the quantity N divided by 2 minus CF multiplied by H. To make sure you don't make any errors during substitution, let's break down exactly what each of these variables represents. First, L stands for the lower limit of the median class you just identified. Next, N represents the total number of observations in your entire dataset. Then we have CF, which is the cumulative frequency of the class immediately preceding or coming before the median class. Be very careful here, as this is a common place to make a mistake. The letter F represents the individual frequency of the median class itself. And finally, H is the class size, which is the width of your intervals. In the next few slides, we are going to walk through a real-world example together, where we will use this exact formula to find the median weight of a group of students. Real-world example. Now that we have understood the theory and the step-by-step process, let's put everything we've learned into practice with a real-world example. Imagine we are looking at the results of a health survey where the weights of 40 students have been recorded. However, instead of a standard table, the researcher has provided the data in that less than format we discussed in the previous slides. Our goal here is to calculate the median weight of these students. Take a look at the data provided in this table. The first column shows the weight thresholds, and the second column shows the number of students. For instance, the first row tells us that there are 8 students who weigh less than 40 kilograms. Moving down, we see that the number of students weighing less than 50 kilograms rises to 18. This continues up to the final row, which shows that 40 students weigh less than 80 kilograms. As you can see, these numbers in the second column are our cumulative frequencies. In the next slide, we are going to use the conversion steps we just learned to transform this into a standard frequency distribution, so we can apply our median formula. Solution breakdown. Now that we have our raw data from the previous slide, let's walk through the actual conversion process. In steps 1 and 2, our goal is to transform that less than table into a standard frequency distribution. First, we look at the upper limits provided in the example, 40, 50, 60, and so on, and determine the class intervals. By looking at the difference between these limits, we can see the class width, or H, is 10. This allows us to establish our intervals, starting from 30 to 4 and moving up to 70 to 80. Next, we calculate the individual frequencies, which we denote as lowercase f, by subtracting the previous cumulative frequency from the current one. Let's look at the table row by row. For the first interval, 30 to 40, the frequency is simply 8, and the cumulative frequency remains 8. Moving to the 40 to 50 interval, we take the cumulative frequency of 18 and subtract the previous cumulative frequency of 8, which gives us a frequency of 10. For the 50 to 60 interval, we take 30 and subtract 18, resulting in a frequency of 12. In the 60 to 70 interval, we subtract 30 from 36, leaving us with a frequency of 6. Finally, for the 70 to 80 interval, we subtract 36 from 40, which gives us a frequency of 4. Now that we have this completed standard table, we are ready to move on to the next slide to identify exactly which class contains our median. Identify the median class. First, let's look at our total number of observations, which we denote as n from our previous calculations. We know that n equals 40. To find the middle point of our data, we need to calculate n divided by 2, which is 40 divided by 2, giving us 20. This value, 20, tells us that the median is the 20th observation in our data set. Now, look back at the cumulative frequency column in the table we just constructed. We are searching for the very first class interval where the cumulative frequency reaches or exceeds 20. If we check the first class, the cumulative frequency is only 8. Moving to the second class, it is 18, still not quite there. However, when we look at the third class, the cumulative frequency jumps to 30. Since 30 is the first value in that column that is greater than or equal to 20, we have found our target. Therefore, we can officially conclude that the median class is the interval from 50 to 60. Keep this class in mind, because in the next slide, we will use its specific values to plug into our median formula and find the final answer. Now that we have successfully converted our less than table into a standard frequency distribution, we need to move to the next crucial step, identifying the median class. Calculate the median. Now that we have identified our median class as 50 to 60, let's bring everything together to find the final answer. We will take the values we've gathered from our converted table and plug them into the median formula we saw in the previous slides. First, let's identify our variables. The lower limit, represented by lowercase l, is 50. Next, we need n divided by 2, which is our halfway point in the data. Since our total number of students is 40, 40 divided by 2 gives us 20. Now, be very careful here. This is where many students make mistakes. We need the cumulative frequency of the class preceding our median class. That would be the cumulative frequency for the 40 to 50 interval, which is 18. Our frequency, or lowercase f, is the individual frequency of our median class, which we calculated as 12. Finally, our class size, represented by lowercase h, is 10. Now, let's substitute these values into the formula. We start with 50, then add the quantity of 20 minus 18 all over 12, multiplied by 10. If we simplify the numerator, 20 minus 18 leaves us with 2. So, our equation becomes 50 plus the fraction of 2 over 12, multiplied by 10. To make the calculation easier, we can simplify the fraction 2 over 12 down to 1 over 6. Now, we multiply 1 over 6 by 10, which gives us approximately 1.67. Adding that to our lower limit of 50, we arrive at our final result. The median weight is 51.67 kilograms. In the next slide, I will highlight some common pitfalls to watch out for so you can ensure your calculations are always accurate. Common mistakes to avoid. First, watch out for using the cumulative frequency as your frequency, or f. This is perhaps the most frequent error I see. When you are looking at your median class, do not grab the cumulative frequency value from the table. Instead, you must use the individual frequency that you calculated during our conversion step. Remember, f represents only the number of observations within that specific interval, not the running total. Second, pay close attention to your class intervals. It is vital that your intervals are continuous and properly structured. If your upper limits are 40, 50, and 60, your intervals must be 30 to 40, 40 to 50, and 50 to 60. If you don't establish these lower limits correctly, your class size, or h, will be wrong and your entire calculation will fail. Finally, be very careful with your selection of the cumulative frequency, or CF, in the formula. When you are plugging values into the median formula, the CF you use is the cumulative frequency of the class immediately preceding the median class. It is not the cumulative frequency of the median class itself. Now, before we wrap up, I want to pause and highlight some common pitfalls. Even if you understand the concept, it is very easy to make a small slip-up that changes your entire answer. If you can avoid these 3 mistakes, you will find that the process becomes much more manageable and accurate. Key takeaways. First and foremost, remember that conversion is mandatory. One of the most frequent mistakes students make is trying to plug the numbers directly from a less than table into the median formula. You must remember that the formula requires individual frequencies, so you cannot skip the step of transforming that data into a standard frequency table first. Second, keep a close eye on your upper limits. In these specific types of distributions, the values you see in the table represent the upper boundaries of your class intervals. This is why we use the difference between these values to establish our class size and lower limits earlier in the lesson. Third, let's reinforce the method for frequency calculation. To find the individual frequency for any class, you simply take the cumulative frequency of the current class and subtract the cumulative frequency of the previous class. It is this subtraction step that turns our cumulative data into the individual frequencies we need. Finally, once you have successfully completed the conversion, the formula application becomes much simpler. Once the table is converted, the process is identical to finding the median of any standard group data that you have studied previously. All right, we have reached the end of our lesson. Before you move on to your practice problems, let's quickly recap the key takeaways to ensure you have a solid grasp of this concept. If you follow these steps systematically, you will avoid the common pitfalls we discussed and arrive at the correct median every time. Great job today!